Hello and welcome to a Maths with Harry lesson. In this video we're going to have a look at graphing quadratics. Now you can see on the screen here I have got myself a quadratic. I don't know what the quadratic is, it's just in general form. The reason I don't know what the quadratic is because I've got A, B and I've got C and I don't know what A, B and C are. So what I could really say here is where A, B and C are given. And what I mean by that is they're given in the question. We know what A, B and C are. Now on the screen here you can see I've got three things and I've got the coefficients of x squared, the coefficient of x, and the constant. And what I'm going to do is I'm going to kind of fill in what each of those three things mean. Now the coefficient of x squared is A, and if you're unsure what coefficient means, it's just the number in front of, in this case, x squared, okay? Now, in front of x squared, we've got A, so A is the coefficient of x squared. So we can then say the coefficient of x is then B, and I'll highlight that in green there. And then in yellow, the constant is just the plus C on the end. And the reason the plus C is called a constant is because there's no x attached to it, okay? It's always just going to be plus C. So what I'm going to do is I'm going to tell you why A, B and C are actually really important when we're graphing quadratics, okay? So I'm going to have a look at A, and with A, the coefficient of x squared, we want to consider whether A is positive or whether it's negative. Okay, it doesn't matter really what A is, we're just wondering whether it's positive or negative. So I'm going to write this in red. If A is positive, then what we get is we get a general shape that looks like that. Okay, and if I hold down, it will turn into a nice shape there. So it's like a U shape, okay? If A is positive, we have a nice U shape. If A is negative, then what we get is the same shape, but upside down, like that, okay? And the way people remember that is if A is positive, then we get this kind of smiley face or a smiley mouth. If A is negative, then what we get is this sad face or a frown, okay? So positive, it's like a U, negative, it's like a curly N. Alright, so those are the two shapes of a quadratic that we can get either going upwards or going downwards. And like I said, it depends on the sign of A, okay? Now B just determines the gradient at which the curve here goes through the y-axis, okay? So the gradients at the y-intercept. So if B is, I don't know, if B is 4, then the gradient at the y-intercept is 4. And I'll point that out on a few examples in a minute. The constant is, well, if we think about it, if I set x equal to be 0 in this equation, this term will cancel here because we'll have 0 squared, so that will be 0. And then the bx will cancel because that will also be 0. So when x is 0, we're just left with c, okay? And when x is 0, well, that's when we're on the y-axis. So when we set x equal to 0, we're just left with y equals to c. And so when we're on the y-axis, y is equal to c. And so the constant is the y-intercept. And I'll write in brackets there when x is equal to 0. Okay, so the coefficient of x squared, or A in other words, determines the shape of the graph. Does it go upwards or downwards? The coefficient of x determines the gradient at the y-intercept, and then the constant is the y-intercept of the curve, okay? And remember, A, B and C are given. Right, we're going to have a look at the general shape of the graph. Now the shape actually has a name, and we call the shape the parabola. So the shape of any quadratic is called a parabola, and it's that important I'm going to highlight it in yellow. Okay, now as you can see on the graph here, I have actually got 3 important points. We've got 4 points, but 2 of them are both called 2. And you might understand the reason for that, you might not. We'll get onto it in a minute. What I'm going to do is I'm going to start by labelling or letting you know what the first point is, okay? Now you can see point number 1 is this orange cross here, and that is where the curve, this curve here, crosses the y-axis, and we just said that's called the y-intercept. So I can write point number 1 as the y-intercept, okay? Now I sometimes might shorten that and I'll write it in grey as the y-int, and I'll probably do that because that's just what I naturally do. So in my examples, I might call the y-intercept the y-int, just so I don't have to write the full word down. Okay, and the y-intercept is when x is equal to 0, and we can see that x is equal to 0 because we're on the y-axis here. The x-axis, well, we're on this point. We've not travelled anywhere in the x-axis. We're on the y-axis, and so x is equal to 0. Okay. Right, let's have a look at the second point. The second points here are both those 2, and you can see if this is our curve, okay, what I'm travelling along here, the 2 points here that are labelled 2, they are where the curve, or the quadratic, intersects the y-axis. Sorry, the x-axis. Get it the right way around. The x-axis. Okay, so we can see our curve is coming down here, we're intersecting the x-axis, we're coming across and under, and we're intersecting the x-axis again. Those 2 points there are called the roots of the quadratic, or the roots of the curve, if you like. So we'll call those there the roots, and I'll put at the end that is, well, we're on the x-axis here, aren't we? And we've not travelled anywhere in the y-axis. We're on the x-axis, and so that's when y is equal to 0. And that's the reason when we want to solve a quadratic, that's the reason we set the quadratic equal to 0. Because we want to find these 2 points there. And so y is equal to 0 when we're on the x-axis. Okay? Alright, and then part 3. Part 3 is kind of all the way down here. We're not on an axis, we're not on the y or the x-axis, we're down here, okay? And if you notice, well, the quadratic, I don't know the equation of this quadratic, I just drew it at random. The quadratic is coming down here, and then we start to pass through this third point, or point number 3, and then we start coming back up, okay? So we call point number 3 the turning point. You might have seen that at GCSE, but we call it the turning point. And there's a bit of information that I need to tell you about the turning point, okay? From this graph, we can see that A is positive, okay? If we had y is equal to ax squared plus bx plus c, the quadratic is going to be in that form for values of a, b and c, but I don't know what those values are. Our a here we can see is positive because we've got this nice shape here. Just like I introduced there, a is positive, so we've got this shape of the quadratic, okay? Now, this turning point can be of 2 things. It can either be a maximum or it can be a minimum, okay? So I'll write that down here. Can be a maximum or a minimum. And if we think A is positive here, our graph is coming down and then we're hitting the turning point and we're going all the way back up. And remember, I should actually maybe put arrows on the quadratic there, because we can see we're actually never going to end. This curve is never going to end. It's going to carry on all the way up here. We just have to end it at some point, because if we didn't, it would just carry on forever and we'd never stop finishing drawing the graph, okay? So what we're doing is we're coming down, and we can see this point here is the lowest point of the curve. There's no point down here that's lower than this point 3. And so in this case, what we've got is the turning point is a minimum, okay? If we, I don't know, let's say we did it in red, we drew a curve, and let's just draw it on the same graph like that. I don't know what the equation is, but that's my curve. We can see that we're going to have arrows like that, and the curve is always going to continue down there. Okay, you can see we're never, and I could draw it on actually, we're never going to finish the graph down this way. Okay, it's going to carry on like that. And so we're never going to get any higher than this point here. That yellow point there is the turning point of the red dashed graph. Okay, we're never going to get any higher than that point. And so in this case, the curve has a turning point, and the turning point is a maximum because we're never going to get any higher than that point. Okay, so hopefully that makes sense. Now I'm just going to get rid of the drawing there just so we can have our original drawing back. And I think I've mentioned everything about those 2 points. The next thing I want to mention is what this line is doing here, and I'm going to put that red dashed line onto the graph in a minute. I'm going to put that, and you might have to be able to see this just from looking at the shape of the graph. From looking at it with your eye, you might be able to see that there is some kind of symmetry going on. And the symmetry is at that point there. What we can see is if we put that as like a mirror, if you like, we've got a perfect line of symmetry down the centre of the curve, and it passes through the turning point. Okay, so we know then that, well, this is a line of symmetry, so we know that, and I could put it on here, that line and that line, just from this route to the line of symmetry, is exactly the same length as the line of symmetry to that route, because the curve is symmetric about this line. Okay, and that line is halfway between the 2 routes. We can use that to help us in a little bit. You might not know, you might not need to know that, or you might not need to use it, but it's just something useful to know so that you're aware of it. Okay, let's have a look. Well, how do we find the turning point? So we know how to find, or just read off the equation, what the y-intercept is, because it's that is just our c value. We also know how to find the roots, because we've done that in previous videos. You just solve the quadratic equal to 0. But how on earth do we find the turning point? Well, you've actually found the turning point in a way in previous things that you've done. I've done a video on completing the square, and to find the turning point, all you need to do is you need to complete the square. That's all you need to do. Okay, now let's say we have a quadratic, y is equal to, and we don't know the values of a, b and c, so it's in the general form, ax squared plus bx plus c. If we complete the square on that, what we will get is this. We'll get a times x plus p all squared plus q. Okay, we don't know what p and we don't know what q are because we don't know what a, b and c are. We'll look at some examples in a minute, but this is completed square form. Well, the turning point we can just read off of the completed square form of the quadratic. The turning point will be at, and I'll do an at symbol there, it will be at minus p q. That is where the turning point is going to be. The reason it's at minus p is because we take the opposite sign of what p is here. So if we had x plus 3, then we would have minus 3 as our x coordinate of the turning point. And the reason that is you can think about the graph being translated. I'm not going to get into detail about that because you might have done it at GCSE. We'll have a look at that later on in the A-level course. But that's actually the reason why we take the opposite sign here. Okay, so complete the square to find the turning point, and then you take the negative of what's inside the bracket, so minus p and then plus q, so q stays the same sign. Alright, so that's all useful. We know now if we sketch the graph, we've got these 3 important points. We've got a line of symmetry. But how do we actually sketch the graph? The first thing you need to do to sketch the graph is, well, you need to consider whether A is positive or negative, so that in your head you can get a general shape of what the curve is going to look like. Now, it's quite important when you sketch that you don't draw any lengths on the axes, or you don't have 1, 2, 3, 4, 5 on the axes and then have something on the y-axis. You don't need anything. This is perfectly fine, okay? You don't need any units or anything. It's just a rough sketch, and that's why we call it sketching. How do we sketch something? You're not drawing a perfect example or a perfect drawing. It's just a quick sketch of the graph. Okay, so yes, we consider whether A is positive or negative, and then what we do is this. We find the roots of the quadratic. So the roots, remember, are where the graph intersects the x-axis, the 2 points there that are labelled 2, okay? We find the roots of those quadratics, of the quadratic, sorry. Then what we do is, well, we complete the square to find the turning point. So all we do is just write it in this form and read off the turning point. And then what we've got is we've got our important points. We know what the y-axis is because we can just read that off the function. We've then got the 2 roots that we've just worked out, and we've completed the square to find the turning point. So we've got our 3 things that we need to know to be able to do a sketch. Okay, so those are our 3 things there, and then we just sketch the function nice and easily. Okay, so maybe write that down so that you've got it at the top of your page, and then we'll have a look at some examples. Okay, so here is example number 1, and we've been asked to sketch the graph of y is equal to x squared minus 5x plus 4 and find the coordinates of its turning point. Okay, now to sketch the graph, we're actually going to need to find the turning point, so we can just state that at the end. But we need to sketch this graph first. So the first thing I am going to do is I'm going to consider whether A is positive or negative. And that's quite easy, it takes me about 2 seconds. I can see that I've got an invisible 1 in front of the x squared there, and 1 is positive, so I know the general shape of my quadratic. The general shape, and I'll write it in grey here, I'm aiming for something that looks a little bit like that. And for some reason it's not going into a quadratic. No, not going to work. Never mind, we'll have to just go a rough sketch there. Okay, so that's the general shape that I'm looking for. I'll draw it properly in a minute. The next thing I'm going to do is, and I'm going to find the roots of the quadratic. Now to do that, I'm just going to factorise. If your quadratic does not factorise, then you will want to use the quadratic formula. Okay, so then you can find your 2 solutions. This quadratic does nicely factorise, and so I'm going to set it equal to 0. So I will have x squared minus 5x plus 4 is equal to 0. And then if we factorise, I want to find 2 numbers that times to give me 4. So we'll write that at the side. Times to give me 4 and add to give me minus 5. I can see that's minus 1 and minus 4. Okay, so those are the 2 numbers that are going to go in my bracket. So we're going to have x minus 1 times x minus 4 is equal to 0. And then, if you remember from when we solved our quadratics in a previous video, either bracket now can be equal to 0. So that tells me that x minus 1 can be equal to 0, or x minus 4 can be equal to 0. And so x is equal to 1, or x is equal to 4. So those are my 2 roots of the quadratic. So I'll write root 1 if you like, and that can be root 2. So I'll put those on the graph here, and we can see, well, the roots are on the x-axis. We've got 1 at x equals 1, so I'll put that about there. And then we've got another one at x is equal to 4, and so I'll put that about there. Remember, it doesn't have to be to scale. We don't need any lengths or units on our axes. It's just a rough sketch. Okay, so those are the 2 roots there. Then what I'm going to do is, well, the next thing tells us to complete the square of this quadratic. So let's do that. We have got x squared minus 5x plus 4. That, when we complete the square, we're going to take x, we're going to halve the coefficient of x and square it, and then we're going to square this number in the bracket. When we do that, we will get, not an equals, we will get plus 25 over 4. Okay? So what we do when we do that is, should be negative 25 over 4. We take that away. So what we get is we get that squared, so we can do 5 squared and we can do 2 squared, and then we get minus 25 over 4. But also, what we need to do is add 4 on here, because that's what was on our original quadratic. So if we add 4 to that, and I'm going to write it as 16 over 4. That's the same as adding 4, and the reason I do that is so I can combine those fractions together. Okay? Now when I do that, what I will get is I'll get x minus 5 over 2, just write that 5 a little bit neater. We'll square it, and I will get minus 9 over 4. Okay? So just simplifying those two fractions there. Now that is in completed square form, I'll write that there, that is completed square form. What I can do is I can read off the turning point. So I can say, and so the turning point is at, and it's going to be, well, we're going to change the sign here, remember? Here we had a positive, so we took the negative of p. So we're going to have minus that, so we're just going to flip the sign. So it's going to be 5 over 2. And then I just take this number here. So minus 9 over 4. Okay, so again, I've took the opposite sign of 5 over 2 there, and then I just carry this number down here. So that is my turning point, okay? That is the turning point of the curve. And now I've kind of got everything that I need. I can also say as well, the y-intercept, and I write it y-int, is y is equal to 4. Okay, and the reason I can say that is because, well, that is my curve, and c here is plus 4. So my y-intercept is at y equals 4. Okay, so I'm going to write that on as well. That is y is equal to 4, and I'll write it as a coordinate. So 0, 4 there. Here we have got 1, 0, and there we've got 4, 0 from our two roots that we found by factorising. And now all I need to do is draw a shape that looks like this. And then when I've done that, I'll add my turning point on as well. So if we draw a shape like this, now luckily, and it doesn't seem to be working at the minute, I don't know why, no, so I'll just have to do it freestyle. I am on an iPad, so I usually can get a lovely curve. But when you do it freehand, we just want a connected, nice, together curve. Okay, so we want it to be smooth, we want it to be drawn nicely, we don't want it to kind of be like that, that's no good. And also, we don't want it to be like that, that's too U-shaped. We want a nice turning point here. So that's the curve that we should get, or something that looks a little bit like that, okay? And then I can also add my turning point on here, which I'll do in red. And the turning point is 5 over 2, that's the x value, and the y value is minus 9 over 4. So we've got our y-intercept, we've got our two roots, and we've got our turning point. So that is the sketch of the quadratic done. That's all we need to do. All right, let's have a look at example 2. So pause if you want to have a go, and hopefully this one you might be able to have a go at. We'll work through the answer when you press play. Okay, let's work through the answer. Hopefully you had a go. If you did, let's see whether you sketched correctly. The first thing we need to do is consider whether A is negative or whether it is positive. And we can see here that we have got -2. So A is negative, so what we're going to get, and again I'll do it in grey, is a curve, oh, it's going nicely now, a curve that looks like that. It's going to go downwards, okay? And then what we need to do is, well, we need to find the roots of the quadratic. So to save a little bit of time, what I'm going to tell you is this quadratic does not factorise. And you can kind of see that in your head. We need two numbers that times to give me 6 and add to give me 4. No, that's not going to factorise. So what I'm going to do is I'm going to solve this quadratic equal to 0 to find the roots, and to solve it I'm going to use the formula. Okay, so doesn't factorise, so let's use the formula. Okay, so using the formula we will have x is equal to negative b, so -4, plus or minus the square root of b squared, so 4 squared, minus 4 times a, which is -2, times c, which is -3, all divided by 2 times a. Okay, here we've got a is -2, b is 4, and c is -3. So all I've done is just substituted into the quadratic formula there. And then I can simplify a little bit, so we're going to have x is equal to negative b, so -4, plus or minus, well 4 squared is 16 and we're square rooting that, minus, we've got 3 minuses here, so we're going to have a minus in total, and then we've got 8 times 3, which is 24. Okay, and I'm just having a look whether I have done that correct. No, I haven't. Let me have a little think. Have I done that the right way? 4 times 8, 4 squared is 16. That should give me minus, oh yes, that's going to give me -8. I have done it correctly. I was just checking with the solution. Okay, so that's perfect there. Then what we're going to do on the bottom is we're going to get -4. Okay, then we can simplify what's under the square roots, and we're going to have -4 plus or minus the square root, and we'll just make that a straight square root there. And then 16 minus 24 gives me -8, and that's still all over -4. Okay, I've got the solution in front of me, and I've also just worked through it myself. We can see that, well, try and put that into a calculator. You might have come through this error yourself, and when I said at the start of this solution that we're going to use the quadratic formula, you might have just tried it yourself. This is not going to work, and what this tells us is that we've got -8 under the square root, and that tells us that we have no real solutions. I've got a calculator here, and I'm going to put in the square roots of -8, and what I get, I don't know whether you can see that because I think it is too dark, but I get a math error, okay? The reason I get a math error is because, well, you give me two numbers that times together to give me a minus number, okay? Two numbers, sorry, that times by itself that gives me a minus number, that gives me -8 in this case. Well, that doesn't work. We don't have any real numbers. You don't have to worry anything about that. In our case, we just say there are no real solutions to this quadratic, okay? So no real solutions, that tells us. And in terms of the sketching case, there are no roots, okay? Now we'll have a look in a upcoming video, it will already be on the channel, we will have a look at the discriminant. And the discriminant is the part of the quadratic formula that's under the square roots. If you haven't had a look at that, it might be useful if you want to understand a little bit more about why the quadratic formula doesn't always work, to have a look at the discriminant. But for this case, we're just going to say there are no real solutions, so we have no roots. Now if we scroll back up to the top, the roots tell us here where the graph crosses the x-axis. And if we've got no roots, in other words, if we've got a minus under the square root, that means the graph is not going to cross the x-axis, okay? Because we have no solutions, we have no roots. So we need to think about another way of doing this. And I can see in the solution here, what they do is they complete the square. And completing the square will find the turning point. Okay, so we've done the quadratic formula. We've got no solutions. We cannot simplify this because, well, what is the square root of -8? It doesn't work. And so we then just need to move on. We need to find the turning point. So let's do that. So let's complete the square now. And to complete the square, well, we've got -2x squared plus 4x minus 3. And I'm going to take out a factor of -2 from the first two terms. So we'll have -2x squared minus 2x. And then we've got -3 because we don't factorise out from the third term. And then I'm going to complete the square on this part of the quadratic, what's inside the bracket. Okay, so I know that x squared minus 2x, if we complete the square on that, will be x minus 1 squared minus 2. Okay, that's what we will get there. So then I can substitute that back in, so I can say, and so, -2 times x squared minus 2x minus 3 will be equal to -2 times x minus 1 squared minus 2 minus 3. And then I'm going to have, if we expand or distribute, if you like, the -2 across the bracket, I'll have -2 times x minus 1 all squared plus 4 minus 3. And then I can simplify that to give me, and I should have a negative here. I'm just seeing where I went wrong. Did I? Oh, sorry, that should be a 1. Hopefully you spotted that. That should be a 1 there. So should that. And then we get +2 minus 3 gives me -1, okay? We are allowed to make mistakes. That's where we learn. Okay, so that is completed square form. So I'll just highlight that in yellow. And then I can just read the turning point off of that graph. Now the turning point is going to be the exact same thing. It's going to be the opposite sign of what's inside the bracket and then this number here. So I can say the turning point will be at, and don't worry about this scalar here. Don't worry, we've got the -2 out the front. I'm just going to take the -1 and it's going to become +1 and then we're going to have -1 from that number there. Okay, so that is where my turning point is. So we've kind of got everything that we need to know now, okay? We have done the quadratic formula. It didn't really work. We tried factorising, that didn't work. And the reason the quadratic formula didn't work is because we've got a negative. And so we can say there's going to be no solutions to our quadratic. In other words, it doesn't cross the x-axis. Then we completed the square, and that's our turning point. So I'm going to put everything on the graph now. I can also say that my C value is -3, and so we're going to cross the y-axis at -3, and I'll write that on there. 0, -3, okay? You can see I was kind of anticipating the graph to be this shape because I put my x-axis quite high up, so I had my shape to draw here. We've also then got 1 and -1, so it comes 1 out about there, and then -1 will be, I don't know, around about there. It's only a sketch, so it doesn't matter. I can connect all of those together, and I'll change that to red. I can connect those points like that to give me my quadratic curve that looks something like that, okay? And I'm going to add arrows on there to say my quadratic graph is continuing downwards. So now we can see, well, it makes sense for there to be no roots because my turning point is there, so it has to sort of start going in the opposite direction. It goes up, 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 and then it goes down, down, down. And then also we need to cross through the y-axis at -3. So we're never going to get through the x-axis. Okay, so that is what the example 2 sketch here should look like. Okay, and I'm just checking that against the solution, and that's perfect. Your quadratic might be a little bit more stretched inwards, or it might be stretched outwards. Doesn't matter, as long as you've got the general shape and you've got those 2 points correct. Okay, here is the last example in this video. It's a little bit different. We are kind of still sketching. It might be useful to sketch it, but the question doesn't actually ask us to sketch it. So you can do if you want to, but we are given a function. We know its minimum, so in other words, we know its turning point, and we're told it's a minimum. So what does that tell us about the shape of the graph? Have a think about that. And it also passes through the point 4, 0. We are asked to find the values of A, B, and C. If you want to have a go, press pause and then press play when you're ready for the answer. If you are still here, alright, let's work through the answer. So, hopefully you had a go. Don't worry if you didn't get values for A, B and C. It's all about just trying what you can do. So, we're told we've got this function. We've got a minimum at 5 minus 3. So let's actually put that on the graph so we can visualise what's happening. 5, we're going 5 out in the x direction, so that's there. And then we've got a y coordinate of minus 3. So we're going down by minus 3. So that there, that red cross, is about where our turning point is going to be. Okay? Now we've also got to pass through 4, 0. So 4, 0, well, we're not going anywhere in the y direction, because remember, that's y is equal to 0. That is x is equal to 4. Okay, let's make that a little bit neater. X is equal to 4. And so I want to kind of, well, that was 5, so that is going to be about 4. Okay? Maybe a little bit further inwards, but it's a sketch, so it doesn't really matter. Okay? So this is my turning point. I'll write TP, and we know this is 4, 0. Now we need to work out the values of A, B, and C. Now look at where this point lies. The y coordinate is 0, so we are on the x-axis. And remember, when we're on the x-axis and the curve intersects the x-axis, those are the roots of the curve. Now I say roots, we need plural, we need 2. Here we've only got 1. Now we're going to go all the way back to the start of this video, and I said it's just a useful fact to know. What can we do to work out the second root in this example using this line of symmetry? Something to do with the length of the roots here to the line of symmetry, and the length of the line of symmetry to that root. What can we use that information, or how can we use it? Well, hopefully you managed to use it, or you're thinking about how we can use it. We can draw in the line of symmetry here. Remember, it goes through the turning point like that, and it's a perfect straight line. We can use that, and we can say there's going to be another root at the same length from this root to the line of symmetry. There's going to be that same root, the same distance apart on the other side. About there. Okay, that's what we're going to have because it's a line of symmetry. So the length here, this length is the same as that length. So we can say, well, we know what the turning point is, and I can actually write that on. It's 5 minus 3. So let's get rid of TP, and we'll write the turning point at that point there as 5 minus 3. So actually this line is x is equal to 5 because the x coordinate of the turning point is 5 and it runs through there, and it's a straight line, so it's at the points x is equal to 5. Okay? So we know the x coordinate here is x is equal to 4. I'm going to write this in orange actually so they can all relate together. There's x is equal to 5. There's x is equal to 4, if you like, that line there. So we're going to go the same distance, but the other side of the line, we're going to add 1 to the x coordinate. So there is x is equal to 6. Okay? Now, I'm just going to go back so that I can write this on quite neatly here. That is the root, or the coordinate, 6, 0, because we had x is equal to 6. Okay, so we kind of go 1 away in the x direction here to get 4, 0 from the 5, so we take 1. So to go the other way, we need to add 1 to the x coordinate to get 6. Okay? Alright, so now we've got that information, I can also get rid of those there. And we've now worked out the other root. Now remember, if we are given a, b and c, how do we find the roots? Well, let's look at example 2. Or let's actually look at example 1 because 2 didn't factorise. To find the roots, we factorise. We know what the roots are in this example. So all we need to do is put those roots in brackets. We know what the 2 roots are, so they will come from the product of x minus 4 times x minus 6. And that will be equal to 0, because what that will give us is, well, x is equal to 4 or x is equal to 6, and those are our 2 roots. Okay? Those are our 2 roots. So if we expand this here, we will get a quadratic. So if we expand that, we'll get x squared, we will get minus 6x minus 4x plus 24 is equal to 0. And then we can collect the x terms to give us minus 10x plus 24 is equal to 0. Now, let's see whether that quadratic will give me a turning point of 5 minus 3. Because remember, we have been told it has a minimum at 5 minus 3. And I've actually got all the information I need now to draw on, and I'll do this in a grey, to draw on my quadratic like that. And is it going to give me a nice shape? Oh, it is. Perfect. Okay, so it's got to cross through those points, and that point as well. Okay, so there we go. There's a rough sketch of my quadratic. So what we need to see is, well, does this quadratic, it's got those roots, but does it have this turning point? Let's find the turning point of this quadratic from these 2 roots. Okay, so if we complete the square, what we will get is, we'll get x, well, half of the coefficient of x to give minus 5. We'll square that, we'll take away what minus 5 squared is, we won't add it like I did last time, we will take it away, and then we will add on 24, so plus 24, okay? Then we can simplify, we'll have x minus 5 squared, and then that will give me minus 1. And so the turning point there is 5 minus 1. The turning point of this quadratic is 5 minus 1, just from switching the sign there and taking that number. Well, in our question, we were told our quadratic has a turning point of 5 minus 3. So what we need to do is, well, we've got the right x coordinate, but we've not got the right y coordinate, this minus 1. We don't want it minus 1, we want it minus 3. So what we need to do is multiply everything by 3. Okay, so I can write here, to have 5 minus 3 as our turning point, we need to multiply this by 3. We will have 3 times x minus 5 all squared minus 3, because we're multiplying all of that by 3. Okay, and then, well, we want to work out what a, b and c are, so we then need to undo the completed square form. We need to say that's 3 times x minus, and that's going to give me 10x plus 25. Let me just check I've done that correctly. Yes, I have, I think. And then what I should have is minus 3, and then multiply all of what's inside the bracket by 3. Sorry, that should be an x squared. We'll have 3x squared minus 30x plus 75 minus 3. And then that's going to give me 3x squared minus 30x plus 72. Okay, and that quadratic, because we've gone from the completed square form that has turning point 5 minus 3. We've kind of expanded the brackets here and got that quadratic. We can then say, so A is equal to 3, B is equal to minus 30, and C is equal to 72.